And L'Hopital's rule is a method for determining limits when they're in the form 0 over 0. So you guys are familiar with that indeterminate form, right? We've dealt with that indeterminate form a little bit before. What are some of the ways we've dealt with 0 over 0 previously?
Factoring.
Factoring was one. What was another one? Multiplying by the conjugate was another one, right? We did some trig function stuff. We did a U substitution. We did some stuff with trig functions. We did a fair number of different things. Well, there's one other thing that works, and I'm not going to prove it this year. If you want to search out the proof for L'Hopital's rule, you can do it online. Normally, we do the proof in class, but we're not going to today. So you can take the derivative of the numerator and take the derivative of the denominator, and then evaluate each of those at A. And that will give you the exact same answer as what you would get if you did the factoring or a U substitution or one of those other methods. Okay? So all you do is take the derivative of the top, you take the derivative of the bottom, and you evaluate those at A. Does that make sense? What you are not doing is you are not taking the derivative of the full f over g using the quotient rule. It is just a derivative of the top divided by a derivative of the bottom. Good or no?
Does it work on non-determinate? Like if you can determine it and if you use it, will it give you the wrong answer?
If you use it on something that is not indeterminate, it will not work and you will get the wrong answer. So this is only good for 0 over 0. For right now, I'm going to extend it to one other case later today. But right now, it's only good for 0 over 0. All right, so let's use this rule to find each of these limits. And I'm going to be a little bit of a pain about this. What do we have to do? We have to first plug in the 2 and show that it is 0 over 0. True? And then normally, I wouldn't require you to do this, but the College Board will not give you the points on the AP test for using L'Hopital's rule unless you actually write out that you are using L'Hopital's rule and rewriting it as the limit as x approaches 2 of the derivative of the top, which is 2x, over the derivative of the bottom, which is 1. Everybody good with that?
Yeah.
So then plug in 2, and what do you get? You get 4. Pretty straightforward.
Yes.
So what about this second one? Sorry about that. Having a little issue with my son in his class. What about this one? What are we going to do? Plug in the 0? And what do we get if we plug in the 0?
0 over 0.
Okay. And then, so we should be able to use L'Hopital's rule. Now, you need to write it out. I'm not going to fully write it out. But if you just abbreviate it like this, they don't count that. But I'm going to do that. So make sure you write it all the way out. The limit as x approaches 0. What's the derivative of root 1 plus x?
1 over 2 times the square root of x.
Yep. Square root of 1 plus x, right? Not just x. And then minus 1 gives us what?
0.
And then over
Just 1.
just 1. We'll plug in our 0, and what do we get now? 1 over 2. Everybody good with that?
Cool.
All right, so what would happen, you think, if you took those derivatives and you ended up getting 0 over 0 again?
Can you use L'Hopital rule again?
You just use it again, and if you still got 0 over 0, what do you think you could do? Just keep using it over and over and over as many times as you need. So you can use L'Hopital's rule as many times as needed. As long as it is still indeterminate each time. Good or no?
What if you never get anything that's like not indeterminate?
You will eventually. If you don't, then you might need to do some simplification of one of your derivatives along the way, but otherwise you will always be able to get the limit. It'll either come out to be like, 0 over 7 maybe, which is 0, or like some number like 8, or you might get something like 5 over 0, which would be undefined, but it'll eventually no longer be indeterminate. As long as you do simplification if needed. So once you do L'Hopital's rule, look to see if you can simplify if it's still indeterminate. Does that make sense?
Yeah.
Okay. All right. So this next one here, plug in the 0, and what do you get?
Zero over 0.
You should get 0 over 0. Exactly. So we'll use L'Hopital's rule to get the limit as x approaches 0. And what's the derivative of the root 1 plus x? We already had that, right? 1 over 2 root 1 plus x. The minus 1 becomes 0. And what about minus x over 2?
Minus 1/2.
And then in the denominator, 2x. So if you plug in 0, what do you get?
0 over 0.
Still 0 over 0. So we will reapply L'Hopital's rule a second time. And the denominator will just end up with a 2, right? And the minus 1/2 will go away. So we just need the derivative of 1 over 2 root 1 plus x, which is the same as 1/2 of 1 plus x to the negative 1/2. So we should be able to differentiate that as what? One half times the negative 1/2 should be negative 1/4 times 1 plus x to the negative 3/2 times the derivative of 1 plus x, which is just 1. And plug in the 0, and what do you get?
Negative 1/8.
Yep, you get negative 1/4 over the 2, which is negative 1/8. Any questions on that? All right, let's take a look at the next one. You guys do this one real quick on your own. I gotta deal with an issue in my house. So give me a minute. We'll still get through everything today. I'll be back in like Okay, sorry about that. Hopefully you plugged in 0 here and got 0 over 0. Is that true?
Yep.
All right, cool. And you remember doing this one with like the circle and the sector of a circle and a couple of triangles and finding the areas and doing a bunch of algebra and then doing the squeeze theorem and all that stuff, yeah?
Yeah.
Yeah, that was a pain. So now we'll just use L'Hopital's rule. And we'll see that this just becomes the limit as x approaches 0 of cosine x over 1, which is just cosine of 0 or 1 over 1. Much easier that way. True? Yes, much easier that way. Any questions on that? All right, so there's another indeterminate form that we're going to talk about that can also be solved using L'Hopital's rule, and that's the form infinity over infinity. So if we think about the limit as x approaches pi over 2 of secant x over 1 plus tangent x, as x approaches pi over 2, what does secant have going on?
Doesn't it start like approaching an asymptote?
It approaches a vertical asymptote, exactly. So you're approaching an infinity value, right? A vertical asymptote is approaching an infinity. And what about tangent of pi over 2? That's also a vertical asymptote. So this ends up being an infinity over an infinity. So we can apply L'Hopital's rule and say that this is the limit as x approaches pi over 2 of the derivative of secant, which is secant x tangent x, over the derivative of 1 plus tangent x, which is just secant squared x. Everybody good with that? Can I simplify secant x tangent x over secant squared x into tangent x over secant x?
Yes.
All right. Now when we plug in pi over 2, what's happening for tangent at pi over 2? It's still a vertical asymptote, right? So it's still an infinity. And what about secant?
Still infinity.
Still infinity. So what do you think we should do?
Use it again or simplify?
All right, one of the two. So let's see what happens if we try to use it again, because it's not going to work. So if we try to use it again, we end up with secant squared x over secant x tangent x, which, if we simplify a little, becomes secant x over tangent x. Well, what's going to happen to that? It's going to become secant x tangent x over secant squared x again. And we're just going to keep doing this little loop between secant x over tangent x and tangent x over secant x. You guys see that? Yeah, no, maybe?
Yeah.
Yeah, so that's going to be an issue. So rather than do that, let's simplify. How can we simplify tangent x over secant x?
You can turn it into sine of x over cosine of x times sine of x.
Not quite. Sine x over cosine x, and then over secant would be over 1 over cosine, right? But you got the right idea. I remember secant is 1 over cosine. And so what does that simplify to? Yeah. If I take the, yeah, just to what?
Sine of x.
Just sine of x, yep. And so what's the sine of pi over 2? Should be just 1. So I'm not sure who it was earlier was asking, you know, what if you just keep getting these indeterminate forms? Well, you could just keep getting these indeterminate forms, but if you simplify, you'll get out of that endless loop. So one way or the other, it'll end up working. Any questions or issues with that one? All right, let's do this one here. The limit as x approaches infinity of natural log of x over 2 root x. As x goes towards infinity, what happens to natural log of x?
It goes towards infinity.
Right, it goes towards infinity. Pretty slowly, but it does. And what about 2 root x?
Infinity as well.
It also goes towards infinity, also fairly slowly. So let's use L'Hopital's rule, which you'll write out every time. The limit as x approaches infinity of 1 over x, right, for natural log of x, over 2 root x should be 2 over 2 root x, and those 2 should cancel. So we've got a limit as x approaches infinity of 1 over x over 1 over root x. Well, if we plug in the infinity, what's the numerator become?
0.
And what about the denominator?
Also 0.
Also 0. So we could use L'Hopital's rule, or we could try to simplify. So let's see if we can simplify. Can't I, since this is a fraction divided by a fraction, can I rewrite it as this, root x over x, if we take the reciprocal and multiply?
Yep.
And now it's infinity over infinity, but we could also simplify that into what? Root x over x is the same as what?
Infinity to the 1/2.
Well, I mean, the root x is infinity to the 1/2, right? But that's still infinity. But what about the x in the denominator? Can't I simplify the root x over the x in some way before I plug it in?
1 over root x.
Yeah, 1 over root x, right? Because x is just root x times root x. So cancel one of the root x's and you get this. Now if we plug in infinity, we just have 1 over infinity. And what's 1 over infinity?
0.
It is nothing. Yep. Good? Any issues or questions on that? All right. We'll talk about one more thing. What type of function increases the most quickly?
Exponential?
Yeah, you're wrong, but we're right. It's good enough for this class. Exponential. Those are the fastest increasing ones that we'll deal with. What about after that? What comes next? Next fastest?
Polynomials?
Yep, polynomial functions, exactly. The higher the power of the polynomial, the faster it increases, right? X to the 100 is going to increase more quickly than x to the 5th. What about after polynomial functions?
Linear?
Linear, but that's still polynomial. So we'll group that in with polynomial. So polynomial slash linear, linear being the slowest of the polynomial functions. Then what?
Rational?
What do you mean by that? You mean like square root functions?
Well, like, I guess like one function over another, like rational functions, like 1 over x.
I see what you're saying. Yeah, those, it's sort of, those can be lumped in with polynomials by looking at what the highest power divided by the next highest power is. So like you can lump those in with polynomials if the degree of the numerator is more than the degree of the denominator. But those don't always increase forever towards infinity. Right, like if you think about 1 over x or x over x squared or x minus 1 over x squared plus 1 or something like that. those functions are not actually functions that increase as x goes towards infinity. They have asymptotes, some of them. So we won't group them in here. I should have specified, we're only looking at ones that as x goes towards infinity, they approach infinity. So right, an exponential, as the limit as x approaches infinity of any exponential is infinity. The limit as x approaches infinity of any polynomial is infinity, or it might be negative infinity, but it's going towards an infinity. So what are some other functions that do that? Root functions and logarithmic functions, right? Which one increases more quickly, the root or the logarithmic? Just looking at this, which one was increasing more rapidly? If the limit for this was 0, what had to be getting quicker or bigger more quickly? The numerator or the denominator?
Denominator.
The denominator. So a root function should be increasing more quickly than a logarithmic function. And those are the last two, root and logarithmic. So this is the order in which functions increase. Fastest at the top, slowest at the bottom. Well, almost the fastest at the top. Anybody know what the type of function that increases more quickly than an exponential function is? Even though we won't deal with it in this class.
What if it's just like a straight line up?
Nah, no, because you can't have a limit as x approaches infinity of that. It's a factorial function. You guys know what factorial is? Other than it just being an exclamation point. Factorial functions. Like 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Yep. Yep, those increase more quickly than exponential functions. You don't have to worry about that though. So let's talk about one more thing. You guys keep talking about how I'm like swassed. I don't think that's true. All right. So what if I gave you this? The limit as x approaches infinity of e to the x over x squared. What should that be? Which one increases more quickly? The numerator or the denominator?
The numerator.
The numerator does, right? So if the numerator is increasing more quickly than the denominator, we should be going towards infinity. And we can prove this now by using L'Hopital's rule, right? Even though it's infinity over infinity, and the derivatives give us infinity over infinity, while the next derivative gives us infinity over 2, right? And so this should be infinity. But this one, the other way, leaves us with a 2 in the numerator divided by infinity and goes towards 0. So if the numerator increases more rapidly than the denominator, it's going towards infinity. And if the denominator increases more rapidly than the numerator, it's going towards 0. So just something to keep in mind is the rate at which different functions increase. You want to know this order. Any questions on anything? That's L'Hopital's rule.